Okay. Good morning, everyone. We are introducing today the thesis presentation. This is on my group: Yasser, Ali Ataya, Fathi, and Ammar, and me, Ihab Khalil. Our topic today will discuss the behavior and design concrete slab on grade. This is our outline. We'll go through the background and we'll discuss the thesis of last semester for people who didn't come. And then we'll go through the scope of work, methodology, task, expecting time, and finally the outcome and table time. Quick overview about last thesis semester. They were testing three types of fibers, the straight, end hooked, and the wavy, and they found out that the wavy is the best one. And then they studied the effect of fiber on mechanical properties on concrete, like compressive strength, duct tensile, flexible, Young's modulus, and workability. And they went through the second phase, where they mixed the wavy fibers, long one and short. They tested on three percentages, like 30% long, 70% short, 50% and 70 and 30%, 70% long and short one. And they found out, or they concluded that the 30% long, 70% short has a better compressive strength, and for the 70% long and 30% short, it has better flexural. And they tested. They took the one and they did the indirect tension test, and they tested the beams under flexural strengths, and they tested beams also subjected to impact loads, and they had three different volumes, and they found out that 1% is the best one. And now I leave you with my colleague Ammar.
A slab on grade is basically a slab with no foundation, no footings. It rests directly on soil. We're going to test four types of slab on grade. One was plain concrete, one was wire mesh, one was fiber concrete, and one was conventional reinforcement. There are four factors affecting the behavior of slab on grade: the soil subgrade reaction, the thickness and reinforcement of the slab, the load of the slab, and the geometry or area of slab. After we get the results, we're going to compare them to the ACI and the US Air Force research paper.
We are going to tackle three issues in the scope of work. First, the behavior and design of slab on grade subjected to heavy concentrated load. In the four cases: plain concrete, wire mesh, and fiber concrete, and conventional reinforcement, under two different types of soil. First, the sand, and second, the sand and gravel. Our second scope of work is very interesting, is really what made us study this subject, which is there is no solid or clear code that says that there should be reinforcement of certain amount of reinforcement in the slab on grade. So we're going to tackle this problem. And finally, providing that the reinforcement fiber concrete is the best solution for slab on grade, as it is, doesn't crack and more economic.
Now I'll be talking about the methodology that we'll be using to prove our theory. First of all, we will be using experimental procedures throughout conducting experiments and tests, and obtaining the results and comparing them to the ACI code and the test will be taking 24 samples. Each sample will be divided, as Ammar mentioned before, on the fiber concrete, the wire mesh, the plain concrete, and the conventional reinforced concrete. And then we'll be taking the 24 samples with area of 1.5 times 1.5. And we will use the 1.5 to 1.5 as a half-scale model, because the regular or normal slab is like 3 times 3, which made us it's not in our budget, and the labs are not available in the area in the lab is not available. So we decided to make it half a scale and use each prototype to be half scale to get reasonable results by using the rules of symmetry. So the 24 samples will be divided as following: 2 plain concrete samples, 2 conventional reinforced samples, 2 wire mesh samples, and 18 fiber concrete samples divided among the 3 volumes of percentages of 0.5, 1, and 1.5. And each percentage will be divided in the combination of 100% to 0% short and long, 50-50, and 70-30. And we decided to make the combination because the long fiber reduces workability and compressive strength while increasing the tensile strength and flexural strength. And the short fiber is doing the opposite. So we're trying to do the best after the 2 combination to get the best result. So we will be testing the, when we talk about slab on grade, we are talking about the concrete and on the type of soil. So we decided to take a sample of 2 boxes. One, as Fathi mentioned before, one will be containing sand, and one will be containing sand and gravel. And we'll be dividing the 24 samples, 12 and 12, among the 2 boxes to test the strength of each sample. And after pouring the concrete, we'll be waiting 28 days, and we divide the samples as I mentioned before. Then we'll be taking the samples to the lab and applying a heavy concentrated load in the center of the slab. And now I'm leaving Yasser to continue the first time.
Okay, so the expected timing for the whole project is going to be 2 days for formwork, 2 days for pouring the samples of concrete, and 28 days for the concrete to gain its full strength, and 4 days for the testing process. The expected problems that we're going to face are problems in transportation of samples, after pouring them and then moving on to the apparatus that is going to test the samples, breaking of the concrete slab, availability of lab engineers and technicians and workers, availability of lab and its facilities. The expected outcomes are compare the 4 cases in the 2 different types of soil rested on, the cracking pattern and load, the load deflection, ductility, energy absorbed, movement strength, and most important, the most economical solution and effective in terms of strength in strength to cast slab on grade. As our main aim is to reach as a mix where we could not use any type of reinforcement, like in large warehouse, like in the airports. The slab on grade is subjected to very high loads. We want to reach that we can use, instead of using reinforced slab on grade, we can make it fiber reinforced concrete. This is our time plan for curing, sun test, etc. And these are our references. And thank you.
Just a quick question about the post analysis. Did you consider doing some post analysis for fiber reinforced concrete in Egypt?
Yeah, well, that's our main aim. We want to reach the optimum economic and most and highest strength that we could reach.
Economic with respect to what?
With the general reinforced. We're going to compare it with the reinforced slab on grade.
With equivalent
bench,
design.
Yeah.
Let me first make sure that I understand your points. You're trying to test a slab on the grade, on the soil directly, right? Okay, what's the function of this slab? What? For highways, for airports?
No.
What?
For large warehouses, like in factories, there are places where it's made. The slab grade is specially made to sustain heavy loads while moving things from the truck. The truck has very high weight, so it's specially made so that it can sustain the high load. Like in
Moving load or stationary load?
Both.
So if
both.
both. So that's why I'm asking if you sustain traffic, for example, your test is not to be concentrated load. You have to test the repetition of this load, not only the magnitude of the load. So this is my question. The function of this slab for what? For trucks to move on it, or only for heavy loads on it?
Well, we also thought of the parking areas for
Yeah.
trucks, and this will cause the high.
If it's parking area, so you
So
need
for these
not
additional-
only the magnitude, but also you need the repetition
Yes, yes.
of the. Thank you.
Any other question?
Yes, just one comment as well. I would like to see in your reference, one of the main references, which is the ACI code for design of slab and grades. Please add that.
I have some comments, and I want you to discuss this, either you know the answer or discuss it with your advisor. What would be the thickness of that slab? The slab that you're gonna test it?
Should I answer that?
Yeah.
Okay, as we mentioned earlier, we're gonna do scaling. So the normal area for a solid slab, it's around 3 meters and 3 meters times 15 centimeters thickness. So we're gonna do 50% scaling. So we're gonna do 1.5 times 1.5 times 7.5 centimeter thickness.
I am just saying that because I'm not sure that scaling is correct. You might scale the dimension, that's one thing, because a slab on grade. But scaling the thickness, I'm not sure how correct is that. Because the behavior of the slab as rigid changes with the thickness. If I can even reduce your scale to 1/10, not 1/2, and make the slab only 1 centimeter thickness, you may say scaling wise, it's a scale. However, the behavior of 1 centimeter thick slab is different flexibility wise, different than the 15 than 20. When, especially because you are applying now concentrated load. If you apply the concentrated load, if this slab is flexible, it will end up that it will rise from the ends and will pressure from the bottom. So the load will be mainly concentrated under the load. If that's a rigid slab, it will be pushing on every point. So this is this thing that you have to find a way to verify for me that scaling is correct. This one thing. The other thing, I again discuss this with your advisor. When you have it in a box, you're gonna make a box and you put the sand or whatever, the underlying soil, and you put that on. The confinement of the sides of the box, will that have effect versus in reality, you don't have the confinement for the sand that's under the slab on grade. So this is something, again, that you have to consider in your test in order for your results to be really valid. The other thing which I concur with what Moran was talking about it, if you are talking about a slab and grade that's going to work as paving material for warehouse or whatever, then trucks will be moving on that. I would say rather than loading put the slab and load it from 0 to failure with the load cell, make it cyclic loading. Put the load and remove the load, and put the load once more and remove the load, and then finally maybe 5, 6, 10 cycles, determine the number of cycles, and in the last cycle continue with the load until failure. So this will simulate the moving load that you have on the slab on grade. So I will leave these 3 points to discuss it with your advisor, and I would like to see in your next presentation that you are addressing these points, whether you will do it or you don't do it because it doesn't make sense, or if it makes sense, this is how we will handle it. Any other question?
Yes, I have one comment. Actually, we agreed together that we have a very important task here regarding similitude. We will have to scale all our materials, the thickness, like Dr. Aizat said, the size of the slab, the reinforcement, maybe the length of the steel fibers as well. I mean, this will be affected because the steel fibers are 5 centimeters long in the real life. How much will it be in our model? I mean, it will also have to be scaled depending on the property of the material and the size of the prototype itself. So this is very important. Yes.
Any other question?
One comment regarding the similitude. When you scale you choose to scale that in half, and you do the assembly tube, you may find that you need to scale down the reinforcement to some non-commercial size. And we may need to use wires instead of the commercial reinforcement. So that could be one of the challenges. So you please consider that in your scaling.
Thank you.